Good morning, gentlemen. Good morning. We are moving on to factors now. Pens down, eyes on the board. I don't know why I have to repeat myself at the start of every lesson. We have done multiples and we have done divisibility tests. Now we are moving on to factors. In simple words, what is a factor? Okay, if I ask you, is 20 divisible by 2? Yes. You quickly check in your head. What's the test for 2? Is 20 an even number? It is divisible by 2, yes? So 2 is a factor of 20. So that means 2 goes into 20 without leaving a remainder. Is 3 a factor of 20? You'll quickly do. Okay, what's the test for 3? The digits must add up to a multiple of 3. So 2 plus 0? 2. Is 20 divisible by 3? No. So 3 is not a factor of 20. Is 20 divisible by 4? Yes. Then 4 is a factor of 20. Do we understand factors? Yes. So how many factors would a number have? Infinite or a limited number? Limited number. So remember this way. F for factors, F for few. So factors are fewer, and that's why I can ask you to write all factors of 30. But with multiples, did I ask you to write all? No. How many multiples a number has? Infinite. So multiples are many. M for multiples, M for many. Factors are few. So that is one thing that can help you remember which one was which. Now, let's find all the factors of 30. Yes? No, I don't want the answer. Now, I don't want you to randomly generate, okay, it goes into 15, 15 goes into 32, 1, 6, 5. Because when you do this random generating of factors, you are likely to miss a few numbers. So I'm going to give you a systematic way of finding the factors, and that's the procedure you'll use. Is that clear? Yes. Yes? Yes. Alright, so rather than finding factors, I'm going to find factor pairs first. So I always start with 1 times the number itself. So is 1 times 30 equal to 30? Yes. So I'm finding the factor pairs. 2 numbers that times together to give my 30. What's the next number? 2? Is 30 divisible by 2? Yes. So 2 times 15. Move on. Is 30 divisible by 3? Yes. 3 times? 10. Is 30 divisible by 4? No. Next number? 5? 5 times? 6. Then what's the next number? 6. But don't you already have it here? That means the factors will repeat now. Once you have listed all your factor pairs in this order, this is the list in this order. So you start. The factors of 30 are 1, 2, 3, 5, 6, 10, 15, 30. And this ensures that you have written all possible factors without leaving any. Is that clear? So, what will be the answer? Factors of 30 are, which order do we write them in? Start from 1. So, 1, 2, 3, 5, 6, 10, 15, 30. See? So, we follow an order. And this way, we do not miss out any factors. So, will 1 always be a factor? Yes. Will the number itself always be a factor? Yes. Yes. So factors always start from 1 and end up with the number itself. Any questions? Yes? Question? Okay. Next one. HCF. What does it mean by HCF?
Highest common factor.
Highest common factor. Like we found the lowest common multiple, now we're finding the highest common factor of 2 numbers. So that means we need to first find factors of 8. And then we'll find factors of 24, and we'll see which number is common to both, but the highest one. So writing all the factor pairs for 8. We start from 1 times 8. Is it divisible by 2? Yes. 2 times? 4. Is it divisible by 3? No. Is it divisible by 4? Yes. But we already have 4 here. So does that mean we're done? Yes. So what are the factors of 8? 1, 2, 4, 8. Can we repeat it with 24? Let's do that. What do we start with? 1 times 24. 2 times 12. 3 times 8. 4 times 6. Doesn't go into 5, and then 6 we already have here. So what are the factors of 24?
1, 2, 3, 4, 6, 8, 12, 24.
Now, once we have all the factors of 8 and 24 written, Highest common factor is the biggest factor that's common to both of them. So let's first circle all factors that are common. So 1, 2, 2, 4, 4, 8, 8. Are these all the common factors?
Yes.
Out of these common factors, which one's the highest?
8.
8. So HCF of 8 and 24 is 8. Clear on that? Yes? Now, using factor trees to find the prime factors. Before we find the prime factors, what is a prime number?
A number that can only be divided by itself in 1.
That's a very good definition. A number that can only be divided by itself in 1. Can anyone give me a definition that has factors in it? Okay, give me an example of a prime number.
97.
97. Okay, give me an easier one so everyone can.
7.
7. Okay. Yep. 7. Is 7 divisible by 1?
Yes.
And is 7 divisible by itself?
Yes.
So how many factors does 7 have? 2. So prime number only has 2 factors, 1 and itself. Now, think carefully. Is 1 a prime number?
Yes.
No.
Because it satisfies the definition given by you. 1 is divisible by itself and 1. Is 1 a prime number?
No.
No, because how many factors does 1 have? 1. So that is why that definition is not the one I'll use. So the definition of a prime number is a number that has 2 factors, 1 and itself. And 1 has only 1 factor, so 1 is not a prime number. Okay? Now, we need to only find the prime factors of 28. And to find that, we draw a factor tree. So we write the number on top, and we're going to draw branches. What 2 numbers times together to give you 28? We're going to write any 2 numbers. 2 times 14. Now, is 2 a prime number?
Yes.
That's it. We can't draw a branch from here, circle it. But 14 is not a prime number, so we move on. Drew another branch. 14 can be written as 2 times 7. Is 2 a prime number?
Yes.
Is 7 a prime number?
Yes.
So circle the prime numbers. That's it. The branch stops where you get a prime number. Then you write 28 equal to this times this times this. And see if it's true. So 2 times 7. 2 times 2 is? 4 times 7 is? Is that correct?
Yes.
So I have written 28 as a product of its primes. So how do we write a number as a product of its prime factors? Doing a factor tree. So do a factor tree, stop a branch where you see a prime number, and then all the numbers that you've circled, write that number equal to this times this times this. Right? Now, there's 2 ways to write it. This is the expanded notation. Pencils down, please. Okay, I think it's lockdown bell, so let's stop the video and